Yes. So thank you so much for having me and for your kind introduction. Yes, I'm a particular maybe individual because I've been contributing both as an industry player as within limits, of course, as an academic player. So as an industry player, I have been most with two large organizations, two corporates, Nokia for around 15 years. And then I joined Huawei around 8 years. Then I went back to Nokia a couple of years, then returned to Huawei about 3.5 plus years. And I have recently joined Rakuten Symphony. And I'm serving as Chief Information and Security Officer for Symphony. Symphony is a vendor recently born out of an operator, ERMI, in Japan. And my role is to secure Symphony as an organization, but also ensure that we have trustworthy product and resilient systems, which was pretty much also my role, among others, at Huawei during the recent years. Yeah, so what I have prepared for you is just a few slides. Perhaps we'll leave some room for questions at the end, which is based on one of my recent papers. So you see, I'm busy with the industry, but I also like to externalize what I think, even personally. Like this work here, I'm not authoring this work as Huawei, Rakuten, Nokia, nothing, as an adjunct professor at the University of New South Wales, because it's pretty much my views, my vision, what I think the future way we are communicating, interacting will look like. And you may download this work actually. We will distribute that during, after this call, doesn't matter. But it's available on the internet. And if you have time, go through that. You have many references, so you become a real expert on what I'm presenting today. And you may also inspire you in what could be the future, where you could contribute and become an important player. So let me start from where are we with 5G, because 5G is also a system that has been recently deployed, but massively adopted. And we can do a lot on 5G. It remains to be seen what we could do with 6G. So when we look at the assigned spectrum and live or planned 5G launches, this is not truly recent, but give us a good view of where we stand. So you see here, we have today probably more 150 operators that they got the frequencies. So they can transmit, they can deliver 5G service. Those frequencies will most probably refarmed for 6G at a time as the system incrementally develops. And here you have where the 5G service is planned to be launched or already launched. So you see the launches, you have mass deployment. In China, but also in Australia, I think we have pretty good services. And if you look at the numbers, this slide is a bit more significant than the yellow one, because it gives you a range and the magnitude of the business, the market, the opportunities, the jobs. And there are a few numbers we need to pay attention to. First is the number of connections. So people already connected end of last year, early this year, and the projection to 2025. So you see that we have more than 200 million already people connected. We're expecting about around 20% of the global population to be covered by 5G by 2025. China, of course, it is where we will have most of the adoption. And if you look at China as an opportunity as a market, we have that in 2020, these are the connection, and basically what we're expecting by 2025, an investment of around $210 billions in this market. However, we need to be a little bit more accurate on this projection or perspective, because if you look in terms of adoption, it's not all happening in China, but practically 5G has been designed to be a global standard and must have. Actually, it's the first technology that allows us to have a unified access to connectivity and communication end-to-end, first time, because even for 4G, we had a standard denoted as LTE, European standard, and then we had the WiMAX push from the US. This is the first time really this is a non-competing technology, but we have this new radio for us available, and the penetration expected by 2025 will be, as you see here, and the 90% of the 5G mobile connection forecast by 2025 will be in North America, Europe, in Asia Pacific. So it is not just about China, but the massive penetration is expected also in the US. Now, what are we connecting here? So why is this important? And then we try to understand the difference between what 5G allows us to do with respect to what is envisioned to be 6G. This is more recent. Statistics, you see the form factors, so the device types that can connect to the 5G. We have many smartphones, so more than 700 announced device type, and more than half of those are available commercially. And beyond that, we have other form factors. So you can connect to 5G service, not only uses your smartphone, but there are modem type, like you're having now to access your Wi-Fi. So there are modems, fixed wireless access, and other type of models that basically bring 5G connectivity to various type of devices. So we think of cars, we think of laptops, we think of robots, and so forth. So it's really a variety of already available technology that integrates with the 5G at various spectrum. So spectrum means we are having the more speed you can have and better service in general. Now, if you look at the technology evolution, where are we today? So today we are here, right? And as we speak, we are having very much finalized, specified all 5G in all its predicted flavor. So we wanted to have three main flavor. The first use case was, okay, connect my smartphone much better. Yeah, so enhance my mobile broadband connectivity. We are here. The system was already finalized, specified, and available a couple of years back. Yeah, and today you enjoy what you're having uses this technology that was specified at that time. Now, this year, actually it was end of last year, but was completed the specification of the system, still 5G, that will support also ultra reliable latest communication service, which means that this interface, this communication is so robust that you can connect not only our smartphone, which has, say, not measure risk, not much requirements than speed, but also robots or other type of platforms that have much more stringent requirements. There are also satellites coming on that particular release. Then this year, we will further enhance the system targeting to connect massive machine type of communication. And going beyond what we say mobile broadband, enhanced mobile broadband, beyond, say, ultra reliable latest communications, thinking of industrial IoT, we will move to some announcement that's release 17 of 5G that will allow us to provide and support the critical IoT, which means any kind of device, sensors, wearables that would constitute an integral part of critical infrastructures. You may think of gas, electricity, ports, and so forth. Okay, then this year we have already announced that this would be further improved. So we talk about 5G advanced with new use case category. And then beyond that, what is it? 6G. So there we go. So as we speak, there is a lot of research ongoing on 6G. So beyond what you get now with the new radio, and the research on 6G has been going now for a couple of years so, and is expected to terminate in 1 or 2 years from now. And then the study item will initiate within the industry players. So they start discussing, okay, what kind of technology we are having. Let us select a few of them that will become the next generation technical specification, and then standards. Okay, that's basically the history. So we are expecting a new, fresh generation by 2030. And from 2030 onwards, we should have ability and capability to enjoy 6G service. Just to land somewhere to understand this technology and the potential use cases, I would like to you to pay particular attention to this slide, because this slide it's an example of use cases and technologies denoted as Cloud X, which are and were enabled by 5G, the new radio. So we will start from this kind of services, and then we need to enhance further the technology to support something beyond augmented virtual reality or cloud gaming. But that's an interesting, it is a really a step where in China, we had also, when I was at Huawei, massive type applications and deployments. If you think of the coronavirus, or if you think of the possibility of supporting broadcasters, the service that China Mobile has offered, and other carriers over there. So what am I talking about here? I'm talking about that if you think of connecting your device of any kind, not only a smartphone, but I'm thinking a goggle, something that can render to you sort of fully immersive experience. It could be an experience real, augmenting your reality. So you watch something, you add something on top, or it could be really virtual, that you are basically projecting a three-dimensional experience, which is not real, but it could be of any kind. And we have this device that if you think of rendering such an experience locally, it's a similar expense, very expensive. And as it is expensive, the gaming, you are downloading your laptop. Yeah, I saw also my son has to subscribe, download, time consuming. I need to always talk to him how to upgrade his laptop, and similarly you discuss how am I upgrading my mobile phone. So every day you need to buy a new one. We don't want this. So what do we want to do then? We want to move these functions, capability and ability to reproduce these digital signals from the device into the network. We say into the cloud. The cloud is just a stack of servers, computers. You have your computer at home. Imagine you have many of those that exchange services among them, and there you can install a lot of application gaming, virtual reality, rendering, virtual reality interaction servers, so that allow the communication between you and the network, and so forth. So by installing this centrally, practically not too far, because this kind of function has to be anyway close to the end user, because otherwise we don't meet latency requirements. So to go from this particular data center and recharge the device, I cannot go more than 100, 150 kilometers. Otherwise, I have too much delay between these 2 points. So what we talk about here is a data center, which is coming very close to the edge. Edge means close to the end user, and particularly where you install your antennas. So that's what we target. So in recap, you have antennas here, the 5G system, then you have your small data center with many services. What you want to do is to move those functions from here to here, and you can do that. Why? 5G allows you to do that. Why? In order to do that, you need to reduce latency, and that's possible because of 5G reduces latency down to 500 millisecond or 1 millisecond two ways across the radio interface. It allows you to increase massively the speed. We are talking about megabit per second, gigabit per second, depends how much spectrum you have available. In China, it's no problem. China, you can get spectrum chunks of 800 megahertz, so you have speed. And then the last thing, it is reliable. So this 5G can communicate here using many links. So if I'm losing, say, connectivity to one of the station, I can receive from another, no problem. That's it. So I can move all of this capability from here to here. So at the end, my devices will be extremely cheap, including I don't need even the laptop. I don't need to buy that. I just need to have something that accesses the system and gets an IP address, or gets a way to reach out my server, and all the capability and ability I still have in my phone can be then, or my phone, it could be a robot, it could be anything, can go to the cloud. And that makes it possible to two things: to reduce costs, achieve an economy of scale, and support also unique technical insights, because here I can develop anything I want. I have plenty, massive capabilities, which I cannot do here. So by doing this, what I have is simply an enabling technology that can construct many businesses on top of a single physical infrastructure that will be shared with many users as a service. I no longer need to spend too much on devices, very simple phones or computers. I just need to get connectivity and then enjoy my services that will be offered as a marketplace. I just subscribe, and then I can choose the games I want to play. Or if I want to use artificial intelligence, I can select the proper skills. If I want an object recognition, I can download that, or actually I can connect services for that particular inference. Or if I want to have an interactive experience, augmented reality, I can just select that application that will capture from my eyes images, will send them back to the net will process them and augment properly based on my position. Yeah, that's, I hope I gave the feelings of where we are and what we are expecting with the future application. But now, why do we need 6G? So, this is my vision, so I'm not representing on this vision any organizations. Today's David's vision. Usually I get it right. So if you look at my talks back in 2015, I pretty much, at the time with the team, we predicted, all what is today in 5G, but also what's coming in 6G. Of course, we couldn't discuss containers, we couldn't discuss Kubernetes. They're just particular implementation of the system, but we already envision, say, the concept and the architecture and the possible. So where are we today? And why I have this vision? I'm not sure whether we can understand that, but let me try to explain this. What I'm saying that all intelligence will be connected with a zero trust through digital twinning using 5G or 6G. And these two technology must work together. That's what I'm saying. So we talk about machine learning, machine reasoning, they must work together. So in short, I'm envisioning how the future will look like and how we interact with intelligence. Yeah, what is intelligence? I came out with a definition which is easy to understand. So intelligence is any entity, a function in general, a script that can implement into hardware, software, doesn't matter. So you may think of a function. Function is something as inputs and provides you outputs. So what are the inputs? The plus as memory. So it's a function with ability to store knowledge. And that's why I'm talking about digital twinning as an approach to that. So you have to digitalize everything. We must. Like in China, I remember I worked on a project in Shenzhen. Shenzhen is so digital. If you don't digitalize, you do nothing. You cannot reduce the greenhouse emissions. And like, think of drive tests or incidents analysis when you think of having a car that, or even an airplane. If you have to start an airplane, you don't need to build an airplane. No, you need to digitalize the airplane. Then you may think of what to change, modify. So what I'm saying here is that, intelligence means we need to have ability to represent knowledge. And my view is that will be through mostly digital twins. First thing. Second, has to be zero trust model. So that means has to be zero trust means you can trust. So it has to be secure. Security is nothing else than ensuring three things. First, you need to be authenticated. So you need to be identified. Who are you? So that's authenticated, and you need to authorize. Yeah. And then you need to be accountable for. You need to be traceable. You need to, that's it. So that means this intelligence has to be connected with this kind of mechanisms in there, because we want to trust. Yes. Then the other point I have here is that we need to use 5G and 6G because we need to have new capabilities and ability to ensure that we exchange these services with a large degree of reliability, speed, low latency, and so forth. And then machine reasoning has to be machine learning. Machine learning is not working. So you have yeah, it works. But I have also given speeches to show you like machine learning, how can be tricked with adversary samples. Like you have images, cats, humans, you can trick them. So it's, in order to solve these biases, problems, we need to have a more advanced technology. And that's why I'm saying you need to have reasoning systems along with path recognitions. Yeah, beyond that, so that's my, then I'm concluding at the edge, has to be at the edge. Edge means around me. Edge of the network, not at the core. That's another edge to internet. No, the edge means the one I'm accessing has to be close to me because of latency reason. Now let's see at the trends. Why I came out with this vision. So I proved this now, or now demonstrate mathematically. So first, the intelligence must go centralized, yeah, at the edge. Why has to be centralized? Because here you have an example of one of the most advanced robotic platform in the world. The name is ICAP. I visited these laboratories in Italy. Italy, by the way, is one of the most, I think Italy probably is the most, it's not Japan. Advanced studies, and ICAP is, well, probably the most advanced robotic platform in the world, ICAP. If you compare ICAP performance to an equivalent human, we conclude that AI shall not be used. It's expensive. It's not business viable. So you should use AI only where it is needed. Because if you give to, this is the son of my friend, Professor Roberto Cingolani, a friend I know well and estimate. And this is the son of Giorgio Metta. That is a friend of mine. We were during the military service together. And you compare these two people, these two boys. We have that if you give a chocolate to the sons of Roberto, that is powered by 40 watts. That's our brain. Our brain, how much is it? 40 watts. Easy. Yeah. How much we consume? 40 watts. Then you multiply by time, you have the energy. And then you can say how much tasks you can perform because they calculate the energy eating a chocolate. Okay. So if you give this guy a chocolate, which is an equivalent of these kilocalories, it will work for a week, never stopping, and perform tasks of that not a single machine will ever achieve, ever, never. If you give the equivalent energy to this robot, you see here, 200 watts, and it requires operation per second. It will last no more than 2 hours. So we conclude that power cost per operation, it is from 1,000 to 5,000 higher today in machine than humans. So my conclusion is that, okay, this brain must be reused. So goes here. Goes to the cloud, has to be at the edge. That's my vision. Okay. Intelligence at the edge also, for the reason, has to be shared, has to be centralized, and therefore at the edge, because you have to reduce latency, which means action reactions. So action decision here through a policy and reactions taken locally has to be performed in 5 milliseconds. Otherwise, you throw a ball to the robot does like this, look, my hands, puff, and the ball has already passed through. Okay, so very clear. Has to be very fast in latency, to be at the edge, close to me, close. Machine learning has to explain you, otherwise you can trick it. So you need to have something better than machine learning. CO2 emission, absolutely, there's no way to reduce that unless we digitalize everything. Okay, that's digital thing. And then finally, why 6G? Because if you look at these slides, you may already think how the future looks like. So there will be interactions between humans and a robotic platform, and particularly there will be interaction between intelligence, those functions. They can perform these three tasks. They can accumulate knowledge, represent knowledge of any kind. Digital twins is one way to do that, but there are many other ways of doing that. Process knowledge and then make decisions. So these functions will be connected. That's why we need 6G. So 6G will allow us to shift from the Internet of Things to the Internet of Intelligence. That's why we need 6G. That's the only use case to me that makes sense. The rest, we have already designed 5G, and here we go. That meets all use cases. Now, if you want to translate what I'm saying to performance requirements, technology, then you need to specify technical requirements. And in order to make technical requirements, you need to have investments. Investments, because you don't monetize now. So you need to have a budget and invest, and then have a return on investment at some point. Yeah, not necessarily, because government need to do this. And then the governance, they redistribute the wealth, and they have a need to use this money to make others also in a position that can invest, like collaborative research project and so forth. So I made a list of ongoing activity of research investments on 6G. You have China. It's probably the major investor. So I say multi-billion investment, because even we don't know how much investment, they are great. I think it's pretty much followed by Japan. And since I've joined Rakuten recently, I spent a little bit time to examine exactly what's ongoing in Japan. And yeah, you may see here we have a 2 billion to support the industry research and expected to get technology 2030. And then I have groups to work together, and that's where I am now. And then there is, like in China, a strong beyond 5G strategy, because everybody attempts then to have a return on this investment. So they need to penetrate the market and monetize. Yeah, the industry has to monetize. And here there is a strong ambition, which will be basically to achieve the 30% for 2030 of 6G, which is really, really, really a great attempt. But I will show you how we may achieve that number, how an organization or more organizations could achieve that number through architecture. This slide presents, you have everything in the paper, really detailed. So with references, just have now a feeling of where we are. So this slide is translating use cases, usage scenarios. We think going beyond what is supported by 5G, 5G Advanced, its evolution, and the corresponding technical requirements. So any use case has to be translated into something I can support in terms of technology. And here you have example of those. Now, we are not technical people, so we should not spend much time, but we can think of a system that improves the performance at least to a factor of 10. So we're expecting, for example, more speed. So today we have 10, 20 gigabits per second. We need to achieve terabits per second speed. If you think of the intelligence, exchanging services, how do they exchange services? It's action reactions. I'm learning, I either upload information to improve my skills, and then I need to cascade this into an inference platform. Inference means that you execute. So that's what we need to have in place, much more spectrum. So we need to use all spectra. So not only what we're having today, but we need to go up to the terahertz. So by going up to the terahertz means the spectrum means waves. The higher the speed, the shorter is the wave. So this is very low frequency. This is very high frequency. So if I have this very high frequency, you may think of a wave hitting an obstacle and returning to me. I have that's my eyes, right? My eyes I can see because I have an echo around me, and so does the radar. The radar can do it because the frequency is so high, so it sends a pulse return. So you may think of a system coming that can see. 5G, that 6G at that frequency can really see. sense. That's new technology. So it's like a radar. So you can see the clutter. No longer today, we have measurement. We ask the mobile, okay, measure, report to me, measure. No, then later can send the pulses and then return, see, fantastic. So we need to integrate the sensing capability of radio access with the communication capability. So if I can see, I can communicate better. Like now, you see, I see you, you see me. It's a much better experience than me on the phone. So you see me. Similar, you can imagine what a communication system can do when it can sense what it has around, not only just measurement reported by mobile phone or other sources or devices. Yeah, then we have other parameters, and particularly we see here, it is a system that has to work three-dimensional. Amazing. So today is 2D, so we think of covering X, Y, that's the ground, on ground. We want to cover everything, space, air, everything. Yeah, that's basically our ambitious. Security. Yeah, that's where I'm now spending a lot of time. But we need to have a system that is secure by design. Now, I don't want to go into the details, but I can tell you that there's nothing new, 5G. 5G enhances the security mechanisms we invented for 2G. How does it work? You have a shared secret, a key. Shared, but secret. So nobody should know it. Where is that? It is in your SIM card, yeah, there, and then it is in the core net or somewhere that public people cannot find it. And then through these two keys, we are doing everything. 2G, 3G, 4G, the same. So we are reproducing all the keys to do what? To achieve cryptography. Cryptography is about two things: protecting the confidentiality and achieving integrity. Does not save you as in terms of availability. So you need to back up your information at the end of the day. But that's pretty much how 5G works. Two keys. Out of these two keys, I can encrypt and I can generate, okay, they're called hash or message digests. So anyway, it is a transformation of my messages that I can compare at the two ends to see whether somebody has tampered or has a compromised the integrity, we say. That's it, nothing new. By the way, since I joined Rakuten, I also had a chance to explore the virtualization platforms. So I spent a lot of time because at Huawei we have more virtual machines and pretty much modally. Then I had a chance to go deeper into the containers, into the container orchestration platforms, images, kernels, so operating system. There is nothing new. Nothing new. Still, we have certificates, yeah, encryption of data at rest, if you are talking about databases, motion, if you transmit them. The only thing you cannot protect are data in use. Like now, if you screenshot me, I cannot protect that. So the data in use is not protected. I want to have a way here that we could also have, by design, something better that we are having today. Today, there are only two technologies available. One is from communication systems, which is called 5G ACA or ERP ACA. So that's the two protocols we have developed. Authentication key agreements. Yeah, two flavors because it depends on the access. If I have access via Wi-Fi, I'm talking about one technology. If it is access through the 5G base station, I'm having the other technology. So ERP ACA, that's what I'm enhancing to support Wi-Fi or 5G new protocol. That's it. Two keys, same. Or I have the internet security protocols and standards. They are extremely simple too. What do you have? Open a browser, you see how it works internet. That's it, nothing else. It's a certificate, which I recommend you know how to play with certificates. Sometimes you get, oh, that website doesn't have a certificate. Yeah. Okay, anyway, I conclude here. So the technology you're having today is absolutely old. We need to think of something a bit better. Okay, let's jump in to see what this technology would evolve. I have a 5 fundamental key enabling technology. Our vision is clear, right? So 6G will allow us to have a shift in paradigm, let's say, to move from the Internet of Things or connected people and things, the same, to the internet of intelligence. So we need to connect intelligence. And intelligence, I said, there are these functions with the ability of to acquire knowledge, therefore represent knowledge, process the knowledge, make a decision. That's simple. That's 6G. Now, what are the enabling technology for us to achieve this goal? And I just go through quickly, but gives you a flavor at least of potential investments, new use cases, and how we're going to get there. So the first thing is that the system we shift from a system AI enhanced to a system which is AI native. We need to do that. Today, 5G has made bit and pieces of AI that is, okay, let me improve this performance here, there. Okay, that's pretty much where we are today. We want to design a system that AI would allow us also better communication with less effort to communicate. Because today, when we communicate, we are after our channel capacity. We call it channel bits. We should find a way that we communicate through meanings. Like when I talk to you, even am I using my eyes, you have immediate an impression what I mean. If I say, why don't you go home? Well, go home. Same beats. No, I'm serious now. Huh? We are laughing. Completely different meanings. But what am I transmitting to you? Same beats. Same beats. But if I would like to transmit to you using the beats, my feelings, can you imagine how much data? So we are thinking of using AI to achieve the transmission of meanings. So the capability and ability to detect the meanings behind a limited amount of data. That's the first thing. The second equally important, is that today, when you access a network, it is cellular. So we need to change a little bit the architecture, use satellites, and they are not there yet, coming maybe later in 5G, yes, they will be there. But for 6G is a must. The communication must go through satellite for two basic reasons. Because we need to achieve 100% coverage. So we need to cover everything. Like in Australia, if you go here a little bit, even you need that because bushfires, there's no coverage. There's no possibility of having service. Yeah, you may have public safety. They are using our Next Tetra system. I work for them now. But still, they have a lot of troubles because there's still cellular radiation. Maybe reduce the frequency, longer range propagation, maybe 30 kilometers ranges. But still, if something happened on ground, we are in trouble, particularly if you are on the bushfire. Yeah. So we think of using satellites. Satellites, new type of satellite, which China has already launched a few of them. And there you find on the paper, because they're already testing this services, as it does Rakuten but not using advanced technology, but Rakuten does in Japan for LEO. LEO stands for low Earth orbiting satellites, and we need to have them not too far from us for the reason of latency. Remember, the more far you go, the more trouble you're having with the latency, so the less services you support. If you want to connect a robot, you need to go down latency, action, reaction. And therefore, we can think of integrating the system with this LEO. They range from 300 kilometers to 1,500 kilometers, and they have a footprint very large. So they can cover, you see here, from 100 to 1,000 kilometers. So we can cover Australia, finally. Finally we have coverage. Yes, but yeah, anyway, and also the latency is smaller than if you deployed fiber, because the orthodromic, you see here, the orthodromic surface distance, it is longer than what you get to. In other words, if you deployed fiber today to reach these 2 points, it would be a longer path than passing through satellites. Yeah? Therefore, we also have a system that is excellent on latency. Yeah, the other enabling technologies is sensing. I think I already introduced to you sensing. So the nodes have eyes, so very high frequency, very small lambda. This wavelength of the wave they propagate, 10 micrometer, depends how you want to pronounce it, but it gives you an idea of the resolution of what you get back when you send a path to the frequency. So yeah, they can see everything. So we need to integrate this with communication capability. And then I've already spoken about the security. And here you have direction, I think, important. So we need to, yeah, privacy, even here, it's another long story. We have to use AI to say, anonymize the data in an easier manner than using concealing algorithm. Again, linked to this share secret. No, it's not working. Yeah, it doesn't scale. Yeah, imagine doctors, thousands of data. Imagine to anonymize sensing, you know. Yeah, what do you use? Concealing function? You conceal what? So we need to find other type of technology. Then integrity, as I said, we have an hash function that you say, okay, what do you want to transmit? This, you put on a function and produces a message. Then you do the same at the other hand, and then you compare what is being produced. That's what we have today. It's not working. So we need to think of distributed ledger technology. Blockchain is an example, although there are many challenges that wouldn't be directly applicable to communication services because it will be too slow to the proof of work. So that's the direction. Then share secret, to me, we need to move forward, think of a new way of achieving cryptography and also be resistant to quantum computing. So we think of post-quantum computing cryptography, post-quantum cryptography, that basically we think of creating quantum resistant software so that the future quantum computers cannot simply crack. Although I doubt you can crack the encrypted message today, because we have a fantastic standardized. By the way, the encryption algorithm is public. Yeah, but you shall not know how the key is. The key is here. So what else? 5G for 4G enhanced AI and cloud native security. I already mentioned to that. Okay, they will go too deeper, and then we need to be security by design, which means practically when I'm thinking of a function, design a function architecture, I need to already think from the very first beginning. Am I having in place confidentiality, ability for protecting the confidentiality, the integrity, and availability of information? Or am I, yeah, that has to be done. Yeah, this is pretty much what I wanted to present today. Now it's technical, that's the architecture, how the system will change, but maybe a couple of words about the new services and how I also see and position Rakuten we compare to other vendors. So basically, what we need to have in place to achieve this vision is not only improve the wireless interface, how you access the network and the services. Yeah, that's important, but not so. What is key to me, we need to find a way that we have flexibility and ability to have a constant integration and constant deployment of new functions, new services, anything that you need to have in place to generate new business or create a better experience for the end user, or even make more about that particular a communication, service, or information. Information means data, nothing else. And this is an example we need to have in place so that ultimately we need to have a unified platform where I can install pretty much everything in terms of network functions, that will establish this communication between endpoints, multi-points, etc. But above that, more importantly, has to be in place ability and capability to orchestrate, so improve, provide security, see what is ongoing into the system, and then have a marketplace in terms of BSS, business support system. Like today, it's very complex. You need to provision the SIM cards, deal with the end user, handle the complaints, and so forth. That has to come much better, much more efficient, and also be offered as a service, because I could simply think of building, for example, Rakuten is doing in Germany. But I believe there are other approaches in China as well that you may think of hosting the old services and give to your operator only the ability and capability to do business. That means that you're hosting the BSS. So they only play with the customers whatever the customers is. It could be the consumers, or it could be an enterprise. You may think of in China, for example, connecting robotic platforms, logistic company, ports. At Huawei, we did many of those. That is just what they think of. They should not think of establishing the infrastructure, because infrastructure has to be there and available for everybody. And then on top of that, we should have anything as a service, anything, connectivity as a service, AI as a service, knowledge also as a service, communication as a service, any operation as a service. I'm thinking of, for example, security operation centers are just icons. You want that? Okay, just buy it. That's it. And then you can monitor what's ongoing in what you pay. Usually there is service level agreement. So depending on the business model, if you buy BSS, you need to monitor the BSS. If you buy the OSS, you need to monitor, etc. You need to have this kind of capability. And security is also a service. Because I sometimes want to be secure, sometimes not. There are, for example, communication on the internet. I don't care. There are other communications I need to be protected. Like if I do banking, yeah, check your certificate. Otherwise, you have a problem behind. That could be also offered as a service. So that's pretty much what I want to share with you. This is the system of the future. Yeah, so it will be a system that, as I said, it's not only on ground, but will be on air and on space. On air, on space. That's how it works. So you have a different type of use cases and consumer or 6G and 5G service, which will coexist, by the way, as will coexist with Wi-Fi. It's not going to disappear. It's going to be there because it's a different use case. Like at home, I use Wi-Fi. Because 5G cannot penetrate it here yet. So yeah. Or because 5G comes only outside my door. So I need to relay that indoor using Wi-Fi. Why not? Why not? So it's Wi-Fi will increase. I mean, Wi-Fi 6 achieves 10 gigabit per second nicely. Yeah, peak. Then you have a problem to backhaul that. But and then Wi-Fi 7. So that's basically where we are on ground. And then on air, we will use satellites. On air, we will use the drones, connectivity to drones, but you can also play the role of a cell. Like if this guy here is out of coverage, I may connect, like a disaster area, in China, there are a lot of problems there, fire. So you may think of providing connectivity, launching drones, and then the drone will basically allow this mobile phone, again, to reach out the network, the services, and probably the police, so the police can send. Yeah, that's on air. And then the other type of device, high altitude platforms or aircraft. Yeah, but more importantly, we will make use of LEO, low Earth orbit satellites. This China has launched that. So you may follow this development. This will provide us access and backhaul. I explain you the difference. Access means that you have many devices that require a communication service. So you need to ask. So you need to provide access to the service. This is a one-way communication between the users and that particular satellite. The satellites will admit you, provide you, so that's access. Then the question is, if I admit you, then how am I reaching the remaining part of the network? That is backhauling, yeah? So I need to have both of these capabilities. So here you have an example of backhaul, meaning that the access is here. You see this guy here connects to a neural edge, a next generation base station here, but then he wants to reach a service here. Perhaps here is discontinued. So what happens is that this is forwarded to the satellite return down to the service. Yeah, here is not to scale, but gives an idea of what we're talking about here. Geo means not moving with respect to an object on Earth. They are moving, but they're not moving with respect to Earth. Very far, but they have a very large footprint. They're already there. The new thing are those guys here, LEO, VLEO, very low Earth orbit. That is what we will experience in addition to connectivity on ground. So that's pretty much what I wanted to share with you. Perhaps, I don't know, Hans, whether we have time for questions.
We have a few questions here coming from the student. Yeah, I think thank you, David. That's really very fascinating what you just talk about. It made me feel like this 6G is very much like living in a whole new world. Where before, I think a lot of my understanding is more related to speed, kind of much faster speed in terms of connection. But I think what you talk about is also related to scale. So it's not just about one devices or one sector that is going through changes, but it's many devices.
See here the many use cases, right? So it's
so
they're all intelligent platforms. So like a car, look at Huawei now, it's coming out with an onboard unit, which is we call it cloudlet. Cloudlet means small cloud, small data center. So you have containers, images, you can put all of that then is in relation and connection with the backend, which is yet another cloud platform. Sorry to interrupt you. Yeah.
Oh, no, but it was really interesting. And also particularly what you mentioned about a service as a model now becomes more and more prevalent and important, like because of a lot of capability to externalize a lot of activities for the companies, then the role of the business in the future probably more will be emphasizing on service and service as a business model.
Yeah, it's just an example of, I'm not sure whether you see, that's just an example. Which, by the way, there will be other type of offering. This is just reflecting what it is projected on Symphony, on the Rakuten communication platform. But there will be different type of approaches, not necessarily represented on what I've shown you today. But again, in the paper there are many articles.
Yeah. And then finally, I think besides the speed and the scale, I think what you talk about in your final slides about the space is also really very interesting, because it's really broadened our imagination in terms of how we imagine about space. Before, we focus much more on the ground part, even the way that how we operate, how business operates, but then you very much broaden it to air and also to space, so which is really very fascinating, because that's where we're seeing a lot of the things that is happening in the space area. Lots of new initiative and everything. I would think maybe that a lot of it is linked to this new technology that every country.
But the space was there. So if you think of GEO or MEO, but they do not meet requirements to thermal agency. For example, if you want to control a robotic platform, you can compare, for example, if you are having at home, it's 1 second. So if you have at home, you can compare what you get through terrestrial distribution system, like broadcast, and you receive the same signal on another television through satellites, is 1 second delay. So 2 ways, 2 seconds. That means, but it's not because of you don't have enough transmission capacity. It's because of the distance. So it's the speed of the light that is 1 millisecond means 300 kilometers. 1 millisecond, 300 kilometers, not much. We need to stay below 5 milliseconds, at least 10 milliseconds to close the loop for important use cases, which was not achievable at this altitude. But that's why LEO is so important. By the way, again, AST Space Mobile is a Rakuten organization that they have already an offering in Japan, and it's there. It's not fantasy. As I said, China has already launched those for 6G. Rakuten is offering coverage already today on 5G mobiles using LEO. It is a joint venture between Rakuten and Vodafone, AST Space Mobile. And the architecture, because the satellite is nothing else than a flying base station. So we're thinking of the same architecture here, could be containerized. So you can upgrade the software here as you're doing here. Easy. Yeah, just pull new images and that's it. You can upgrade that to the new wireless interface, new services, new capability, and our ability to have better safety, or anything.
Thank you, David. We have a few questions actually in the chat box. I might just go through them. The first question we have is one student asked you, that's Guo Xu. I just heard the threat of the 6G might bring us. So here's Guo Xu. So in terms of this, what are some specific implications for marketing and consumer like ourselves?
Specific implication for us is in terms of benefit, or in terms of drawbacks. I see benefits because what we will be surrounded is the new services. So you may have AI as a service. So have ability and capability of using also these distributed functions to perform for us many more tasks that we're having today. So if you think of a coronavirus, I'm thinking of China. They were building all this AI with Huawei also to detect the images and then measure temperature. What the 6G would allow us to go far beyond that. So it would allow us to achieve much more sophisticated use cases, including, say, ability to transmit meanings. So for us, there are many benefits. But if the question is the threat is because it's becoming so intelligent to replace humans, absolutely not. So there is a I don't know the threat. What threat in terms of security, safety, job losses? I see only benefits. Yeah.
Would you want to elaborate? I see Guo Xu was there. Do you want to elaborate? What do you mean by threats?
Threats is in security terminology means any potential actions that has ability to exploit a vulnerability. That is a threat. So like me as a human, I have vulnerabilities. A threat is capability and ability to exploit that threat. So that is a threat. And then the risk relates to threat and vulnerability. The marriage, so the threat you represent in terms of probability or having the particular action or whatever you may represent behind the threat as an actor, and the vulnerability. If they don't meet, we don't have a risk. So you can be vulnerable as long as they don't exploit the vulnerability. So that's why I didn't understand the question. To me, we are going towards a system that, of course, there will be risks, but can be well mitigated if we think of a security that would lead to safety. Because when you are dealing with the intelligent robotic platforms, we need to think about safety. So you need to make the system secure, protected, so that you don't have risks or major concern. So that's what I mean. So that means we need to reduce the factor between two terms. One is threats that could be there, and the other one the vulnerability of the system. Yeah, that's where we are playing. We need to mitigate both of them. Either you mitigate the probability of a threat to exploit that vulnerability, or you mitigate the vulnerability by, say, patching or improving. And this is the system. That's why I'm pushing to have a system which is a secure by design.
Yeah, I think that's the question that Guo Xu had, because you mentioned about there's some privacy issue, like someone might screenshot you where you didn't know, and particularly you mentioned about a lot of the design related to cybersecurity and privacy. I guess the question is, are you confident that it is possible to be achieved, that this kind of security and privacy by design? Do you think that this is possible?
Yeah, yes, it's privacy means that you have so privacy violation means that you are basically violating. I'm using now the European terminology within the GDPR. So you are violating the data subject rights in terms of personal identifiable information. It could be my face, it could be anything that links me as an individual, as my body, yeah. And in order to solve this problem, does the GDPR resolve it? No, the GDPR fines you, fine. So if you violate that, okay, you have to pay up to, if I remember correctly, 4% of your revenue. So if like you export my face from Europe without informing me, and you sell, now am I wearing this in China, you are liable, yeah. Because, but you don't have a mechanism to protect me. But how do we protect that? Yeah, we're thinking of anonymizing this. So as long as you encrypt, you anonymize the information, you play with metadata. Metadata is data on data. That's what it means. Then I think is we will achieve that. So because we think of today, if you think of 5G, we conceal. Concealing means to hide the identity of the individual. Later, we need to go beyond that. So also my face, if it is my face an object of communication through the journey, unless I am giving consent, has to be anonymized. Means we need to decouple what you transmit from me in a way that it's no longer a personal identifiable information. You can do that. AI, the algorithm. So if you read the paper, there are many possibilities, also the federated learning, so that you don't need to capture my face entirely. Perhaps you can capture this one from here, my nose from here. I'm just now inventing. That's a way of federated learning. You learn how I am, but it's so distributed that you cannot recompose it. So there are many, many techniques I am disclosing, because we need to face this issue as the system will have sensing capability. Of course, the resolution is not like what you see me on the screen, but you can pretty much identify me because the clutter, the echo illuminating my body, you may see me, you know, that's me, maybe because I'm bent. Or yeah, I agree with you, but there will be capability and ability to anonymize this information, store securely, transmit securely. The issue remains at news. When information is in news, there's no protection. Now you're using me, I'm using you. I can see, you mean you here? Yeah, you're not protected, see? Because we are using our data. So I can screenshot you. And you say, yeah, but I have disabled my computer. No, you haven't, because I have my camera here. I can take you see my phone. You're done. So that's a big issue. And in that sense, we need to think of, it's called physical security. Physical security, that means I need to be reproduced in an environment in which I am detected. If I do this, I cannot do this. And then like I can open document, confidential, took this, I cannot do this, yeah. I could be detected because, you see, my computer could detect me that I'm doing something improper. But yeah, it's a long story. So we need to have those mechanisms by design. We cannot patch it, so it's, and if we don't solve that by design, the adoption will be at risk. We have many technologies not used because of the, I guess at home you're having a smart TV. We do have it, but we keep the camera down. So you have a smart TV, and we keep it, there is a, yeah, we just obscure it, yeah. Because you don't trust it, yeah, as simple as that. So we should have mechanisms that allow us to protect the privacy and also achieve security and in turn safety. So people tend to mix all of these three things, but they're very clearly defined and separated. We have to target safety first, yeah, and to be safe, you need to protect the privacy and also the security mechanisms in place. But ultimately, what we want to achieve is safety of humans. That's why we exist. All these issues to protect us as humans. Particularly, we need to be protected by machines, all these functions. and benefiting of them. They have to serve us and complement us. Also, the thinking that we replace us is incorrect. So only the tasks that a machine can reproduce at a lower cost could be replaced. The rest not. They are very limited with them. Yeah.
Thanks, David. There's another question actually from students. He said, thanks for the great sharing. I'll be very interested to hear how governments and corporates could manage the infrastructure cost at the early stage of adapting to 6G. Also, any tips for future graduates who are interested in joining the ICT area?
Yeah, normally, if we go back, I gave you examples. Our government incentivize the smart creatives within the countries. And here you can see how much investments they're placed in China, but also in Europe. Europe always attempts to do a lot, and other countries. Yeah, the government has the responsibility of redistributing wealth and enable the creation of ecosystems so that that particular country can achieve intellectual property, can prosper out of the technology. Is essential to invest. Look at, we can take a couple of countries, like Italy is not investing much. So if you don't invest, means you don't have those skills, you don't have those capability and ability to exploit technology, to create new services, to become healthier, in a sense that without technology, today we would have even problems to find the right medicine, to be cured. Even the vaccinations, if you think of the coronavirus, who found that? Yeah, who found it? Would they found in Italy? No. Why? Because they invested. So there's no discovery. So we need to think of, that's the responsibility of our country. And China has a very long-term vision that not so many countries have. Very structured thinking. We need to have a very structured thinking, because this kind of investment will pay back in a long term. And this is where the government comes into place, because there's more players. Like if I have a small company, I want to make money. I need to pay my salary. I need to pay my family. I need to pay my schools. And in order to do that, then the government comes along with you and says, look, if you give me $1, I give you 4. Come on, let's working together. And then, of course, there's constraints. So if you play with the government, they will ask you to share that with the other communities. And then you need to have a consortium agreement with other players. Okay, look, okay, the government wants us to do that, but we can find an agreement among us that we share only the licenses of what we invent between us, and who is not on board now, who has to pay us. So there are various schemes, but the government is fundamentally important to support in long term. And then the other question was what to study and where to develop the skills. And this is also the question I'm getting from my son. And yeah, you'll find in the paper, but let me see. Yeah, what I think is technology-wise, we go towards a system that will be all virtualized. So hardware is important, but if you look at the hardware, who produces hardware? We have, I think, 80%, 60% to 80%. It's in Taiwan. So there's a few factories that they are really producing. I know China now is trying to do that, but yeah, it would take. I heard some public speeches that would take 1 trillion up front, to enter their business, and so it's a long, very, very long term. The hardware, yeah, it's there, evolves, but yeah, but I would, yeah, consider. So if you have ability to play with the hardware, please go. Yeah, the new way. Quantum computing, new way of going beyond the current von Neumann architecture. So it's still around von Neumann. What is von Neumann? Von Neumann decided to have computing, memory, and storage separated. Does that brain separate that? No, so we are wrong. So we may think of new, but based on my experience, I think software is a very interesting, like I'm thinking of a virtualization in terms of containers, container orchestrations, operating system kernels. So you may think of a system that grows vertically on the stack rather than horizontally. I spent 20 years of my career to study how the communication could happen horizontally. So how am I transporting a packet from my phone to another phone, which is remote to me? If I have direct line of sight, then today I can do it. The network allows me D2D communication. Is that the future? To me, no. It's solved. So where's the problem? The problem is vertical. So I need to allow any piece of hardware to make money. So, and that is the stack vertical, where you may think of a virtualized platform with the ability of doing what? Of hosting functions, virtual, that would allow you this communication horizontally. But then you need to play vertically. Once my communication is established, I need to consume service. On the same platform, you should be able to install other applications like I mentioned here and offer them as a service and refresh them constantly, continuously. And that's the DevOps type of approach. So that means the development team has to work with the operation team, particularly with the production environment. How do you do that? You have to virtualize the system. So you have an application, you put on a container. Why? Because you want that to work everywhere, independent of the host operating system, right? That's what you want. So I don't want to spend too much time to create a web application and then I cannot run on a particular machine. How do we do that? We packet some part of the operating system, put in there. That is evolving now, and we're thinking of moving a lot of capabilities to the kernel. So that means the runtime functionalities of that provide service to all these applications. We want to do that. That's the future. And why we want to do that? Because if you think of look at this slide, a packet that leaves this person and then has to achieve, say, this machine here. Look at the journey that would do. This packet goes here, then has to be probably routed here, maybe this guy knows the position of this and pass it here, there. And by doing this, there are many hops and many layers that they need this information exchanged. Yeah, to me, we need to resolve this problem. And this problem could be addressed by thinking of those elements speaking at origin. So like when a packet arrives to your computer, we call it host. It could be a computer, it could be another box. The kernel, the operating system should know immediately where the packet goes. Not the other packet, okay, I pass that to, the control plane of my orchestrator, and then the orchestrator needs to think of, in the ingress, maybe it's that for that container or that container that speaks to other container. No. And then it has to go to that particular function, the function encapsulate that pass on that tunnel. No. So we need to go deeper and think of I call it cloud native security and network. That's a future to me. Cloud native security. And it's a future. And today, for example, since I joined Rakuten, I tried to rebuild the teams and I cannot find this expertise. Why? Because the world is decoupled. People like me are coming from communications, and only in the last few years, I returned. Actually, I'm from computers. So if you look at my career, I've been a computer programmer, computer software engineer for quite some time. It was good. Then I decided to move to the communication because I was fascinated by this packet going this. And then I'm returning to cloud computing, cloud native security now and orchestration. All my security knowledge goes into the cloud because that's my problem. My problem is to secure that when I download an image, I mean, it's the right image and not I have something, a container that spills out and then puts down the whole cluster. So that's to me, the future to me is, I would invest, seeing the demand also, how the system will evolve, the way we communicate will evolve, the way we install offer service towards cloud native security and networking. A lot to do. Yeah.
Yeah.
A lot of business, a lot of opportunities, and a lot of fun too, I think.
Yeah, certainly. I think the way you describe it, David, it's really going to be a very much a new world. I think one more question, one last question. Actually, I'm conscious about time. Is about you talk about this many countries. You talk about 5G has the same standards globally compared to the previous generations of technology. Yes. But now many countries are now competing in investing in 6G. Would you see the possibility of different standards for 6G?
Yeah, this is the questions. It's very, very, very difficult for me to answer. Also because, yeah, now we are entering into the, okay, let me put it in simple. It took us, me included, 30 years. I'm honest here, as a worker or as a contributor. Took us 30 years to unify the standards. Unify the standards means that that I am able to yeah, communicate, but also sell, achieve an economy of scale, and also experience, independent where I am. And that benefits, because if you think of if you don't scale, you cannot have business. That's simple as that. And the cost is very high. Yeah, whatever is proprietary, whatever is a limited applicability, high demand, the costs are enormous. So we achieved, finally, a new radio, 6G, that is a unified way of accessing the services, but not only. We went beyond that, because now I'll go a little bit into the detail, but the core network, we first in history that we find a way to unify the whole stack in terms of authentication, authorization, and accounting, which means practically today using 5G in its standalone configuration. So you need to have also 5G refreshed core network. It doesn't depend on the access technology. So you have your SIM card that allows you to use safely and anonymized and protecting your privacy independent of the access. Yes, it took us 30 years to achieve this. Now look at the 6G now. There's a lot of pressure, a lot of discussions, also led to geopolitics, competition. Ultimately, I hope that there should be many, many enabling technologies as with the 5G. I remember at Huawei, we had our own flavor, now we should go into the details, like pulse shape modulation was done by my team. So it's many, many flavors. But then at some point, you need to have a team of players normally. And I think also we'll continue with the 3GPP. 3GPP is just a project where many representatives from standardization organizations, industry, governments, they go and discuss that they will agree on the technology selections. That's done through the study items. So they will study together. And I think it doesn't matter if today we have a lot of competition. Actually, competition is good, because competition, after all, reduces costs, stimulates investments, and is safe. So it's safe because it introduces the diversity in the supply chain, anything. So competition is good. So let's let it go. And then I think at some point, we will be together and say, okay, look, let us choose this technology and specify those as the next generation system, particularly thinking of the access. Whereas I think there will be many, many flavors around the implementation. Because if you think of a virtualization platform, you don't care much the interface. So as I said, I repeat, an interface is just how you move a packet from a host to another that they speak not the same language. Okay, that could be standardized. Okay, be there. But what in the between? What if I have a unified platform that I just care about the ingress and egress, and all the rest could be proprietary? Yeah, if it is virtualized, I think it is that. You're not debating, if I send you a text on Gmail, for example, I'm just taking a platform, you may think of WeChat. If you use WeChat, two people are in communication, for example. Do you care where the network is? Maybe there is no network. You and your friend are on the same database. Just to give you a flavor, do I specify how the WeChat is implemented? No, I need to care, no. So maybe what I'm saying that at the end, maybe 6G are just small debates. It depends on what we want to open. The wireless interface needs to be open. Maybe, but the capability doesn't need to be standardized. And maybe you don't want to standardize. Yet, you need to have ability and capability to have a safe system. Safe system, protecting privacy. That's why I'm discussing about we should achieve a security by design, so that it cannot be easily compromised or patched later, because we are having those safeguards. They're called safeguards in place since the very beginning. So that was the thing. It's a long debate, like many discussions, but at some point they should cool down and converge. I do believe a strong competition will be on the cloud, because it's pretty much, we are shifting paradigm we had with Nokia Symbian to the iPhone now, right? Many operators and vendors, they stick to push you, 5G by me. 6G, you need to replace all the equipment. Right? That was Symbian. Symbian, do you remember all this nice, no, they are too young, but they were nice smartphones, so you wanted to have the other one. Today, I have this, it is Mate 20. Perfect. I just download. I can choose the marketplace from Huawei. I can choose marketplace for Google. Similar here, maybe. You will have a system that you may choose the marketplace of carrier A, or you may choose the marketplace of carrier B. So that's not much around standardization. It's about ability and capability. I'm not standardizing the marketplace or where I find my application, but I might have a regulatory framework that says, okay, look, set to consumer, then you need to comply with including privacy. And that's what needs to be in place, and has to be auditable and verifiable. Yeah, that's what I'm expecting.
Yeah, well, thanks, David. I think that's really a rich thoughts of information and ideas actually coming from your talk. I think that security by design is really something that is very interesting. Particularly, I think it really, I think, make me feel like, so much things we now talk about climate change, which is where different governments need to cooperate together to cope with this global challenge. But what you're saying here is very much another global challenge, where it really needs different governments, on one side competing with each other, but probably on the other side, compromise and collaborate with each other, provide that security and privacy, which is very needed, I think, for these technologies to really, when I see this is happening very soon, seems to be, that will be something that where people, individual citizens like me, will be very concerned about. Yeah. Thank you so much, David, for this fantastic talk. I think we have very, very good, I think, discussion here. I'll post videos I'll share the videos with you. I'll post a video on Canvas so that the students can go through it, because I think there's so much information in the slides and also in the talks. It's probably a very good source of materials for students if they want to learn more.
Yeah, normally I'm connecting on LinkedIn. Yeah, that's a platform currently widely used. It was not earlier, but now I think it's becoming. Yeah, I was in China, so many Chinese colleagues, Huawei, other colleagues, ex-colleagues. I mean, it's very used a platform, and on LinkedIn we have an opportunity to stay connected. And I'm also sharing content, and yeah, it's a way to follow up.
Yep. Okay, and you can see that in this slides, which is David's LinkedIn account. So feel free to connect with him. So thanks very much, David, for spending time again on particularly on the Friday evening, talking to our students.
Thank you for having me.
Yeah,
really refreshing.
Look forward to your next talk again. Yeah, every time.
And I really hope that I mean, this conversation was useful and make our next generation of smart creatives inspired.